It started out with graphene and then it went to functions. I'm doing FOIL to solve x. Next is the expressions. Now I have to see if x is equal to or greater than 3.
All right, this is your question number 1. So let's go ahead and factor this problem. First thing I'm going to do is make sure there's any GCFs. And the answer is no. 1, 5, and negative 36, there is no GCF, okay? Second thing I'm going to do is I'm going to count the number of terms, okay? There is 1, 2, and 3 terms here, okay? So 3 terms is looking like we get to use Xbox. Now be careful. You have to do half of the exponent here of 4 must be this number, 2. Is half of 4 2? Yes. This is good because then we can actually use the Xbox method. So this is 1, so A is 1, B, and C. So I have A times C is going to be negative 36. And your B value here is going to be 5, so 2 numbers that multiply to be, I'm just going to write all the factors, 36, 1, 18, and 2, 3 times 12, 4 times 9, and 6 and 6. Maybe you see it. There it is, 9 and 4. 9 times negative 4 is negative 36, and 9 plus negative 4, or 9 minus 4, is 5. So those are my numbers. Okay, now I'm going to use the box to kind of show you what is happening here. So I'm going to put this whole term here, x to the 4th, always in the top left. The C value will always go in the bottom right. The numbers that we just got here, they are basically splitting the middle term. So this is an x squared, so I'm going to have to write x squared here. All right, the greatest common factor going in this direction is a x squared. Greatest common factor going in this direction is going to be, it's going to be tricky here. It's going to be a negative 9. No, I think it'll be positive. Let's double check after we go through. GCF going in this direction will be an x squared. And GCF going in this direction will be a negative 4. Let's double check this. So x squared times x squared equals x to the 4th. 9 times x squared gives me 9x squared. X squared times negative 4 gives me negative 4x squared. And 9 times negative 4 gives me a negative 36. So that is correct. I'm going to circle these. And that's what I'm going to write above here. So if you factor these, you have x squared minus 4 and x squared plus 9. Okay. Some things that you should notice here or observe is that this one is not factorable over the real. Not, let me write that in a pen color. Not factorable over the real. That's just kind of like where you're at. If you did decide to kind of to get an answer for that one, I'll just show you really quickly. X squared plus 9 equals 0. X squared equals negative 9. X equals the plus or minus the square root of negative 9, which would be square root of negative 1 times square root of 9, which would be x equals plus or minus 3i. And if you put it back in here, you would get a 3i, and a positive 3i. But what I wanted to show you for that's your complex answer. This one, you're going to have to factor again. That's the difference of squares, -4, 0, that'll be 2, and -2. So my answer would be x plus 2, x minus 2, and then x squared plus 9. If you were just doing it over the real. Okay, so that would be answer for question number 1 on your test. Question number 2, which is a factor? Select all that apply. Let's count the number of terms. Do you see any greatest common factor there? I don't. I mean, there is in parts. So there are 4 terms, so you can just factor this by grouping. Now, factoring by grouping or with 4 terms, you have 2 options. You can take the GCF of this one, which I'll do, which I see is an x squared, and then you're left with 3x plus 5. Then over here, in yellow, I see that my greatest common factor is -9, and then I'm left with a 3x plus 5. Remember, you can always distribute to check your answer. So that's kind of like the first GCF. You'll notice that both of them have the 3x plus 5. So I'm taking the greatest common factor of a 3x plus 5. That's why I'm writing it out here on the left side. And then I am left with an x squared minus 9. And then here in red, this one factors again. That is an x squared plus 0x minus 9, so -9, b is 0. That would be a 3 and a -3 is your answer. And so I have 3x plus 5, x plus 3, and x minus 3. So I'm going to select all that apply. So an x plus 3 here. Let's see if I can make that a little bit more transparent. Here, x minus 3 works, and a 3x plus 5. So A, B, and C for that one. Okay, so question number 3 here. I have only 2 terms. Okay, so your choices are the difference of squares or the difference of cubes or the sum of cubes. Okay, cubes is to basically see if you can take the cube root of these. 3 identical numbers, and if you break them down, you can see that so it matches the number on the outside. So all of these guys can come outside. All of these can come outside. This is basically saying that our A value, if you think about it, it's like this. X cubed, right? And 2 cubed. Because x cubed is x cubed and 2 to the 3rd power is 8. So that means our A value is going to be x in our formula, and b is going to be equal to 2. So this follows the pattern of a plus b to the 3rd power equals ab a squared ab b squared. And this is where I'm going to use the SOAP. So S stands for the same of what we started with. O is the opposite, and AP is always positive. Okay, now I'm just going to use my colors to highlight them in. A is equal to X. Oops, don't need that one. and my b is equal to 2. So every b value we're going to put in at 2 here, to the right side of the equal sign. Whoops. So this will be x plus 2, and use parentheses if you need it. This will be x squared minus a is x, b is 2, and your b value is 2. Just go back and now simplify all this. So I have x plus 2, x squared. X times 2 is just 2x. We just call this negative 2x. And then 2 squared is 4. And this trinomial, the second set of parentheses, is not factorable. It's prime. So this would be our answer. And you just put it in there. That's what you would have put in. All right, number 4. What would be the remainder of the polynomial division? Okay, so in this problem, you can find the remainder in 3 ways. You can use long division, you can use synthetic division, or you can use the remainder theorem. I'm going to use the remainder theorem for this problem. I'm going to take this factor. This is a factor because it has the parentheses, and you just set it equal to 0. And what I'm doing here, that's a 2, x equals negative 2. This is my 0. And I can take a 0 and do something like this now. I can make this a function and put the negative 2 for every x value. And my answer will be the remainder. That's why I did it. So negative 2, negative 2. Did you notice every time I'm putting in the negative 2 in yellow there, I'm putting it in parentheses? And then I'm just going to use PEMDAS, the order of operations, to help me simplify here. So that would mean that I'm not going to multiply, I'm going to use the exponent first. So negative 2 to the third power is negative 8. Negative 2 squared is 4. And you can just rewrite all of these or simplify. Okay, now I'm going to use multiplication left to right. Multiplication and division as I go from left to right. This would be negative 24, negative 4, positive 14, and plus 6. So I have negative 28 plus 14 is negative 14. Negative 14 plus 6 would give me an 8. So what is the remainder? The remainder is positive 8. Another way of saying this, because it might come up in a different form, is this 0? The answer is no. So no, x plus 2 is not a factor. It's a different way of saying it. Let me show you guys how I would put this into a calculator. Show you guys, I use one on my iPad called Graphing Calc 83. Put it here. Pull up this picture here. So I have 3x cubed minus x squared minus 7x plus 6. And then I can do table, and we were putting in a -2. And you'll see there that it is, it says it's a -8. Let's double check. 3x cubed minus x squared minus 7x plus 6. Let's double check our work here. -2 cubed is 8. So if I copy the problem correctly, +2, +4, -4, +14, 16, so 20, it is negative. I think I said -8, but you can use the calculator, double check like I just did, and see that this is not the right one. Should have been A. Number 5. The function of f is defined by a polynomial. Some of the values of x and f of x are shown in the table. Which of the following must be a factor of f of x? Okay, so you have some kind of graph. Let's give you a visual. And you can actually just graph all of these. I mean, 0, 3, 2, 1. Put 2 there. 3, 1. Should I just... Okay, 4, 0. And 5, -2. Okay, there's my function there. And then they're asking which of these must be a factor. Just like we did in the last problem, a factor basically means that the remainder is equal to 0. That was what the factor theorem is. Let's write it out. Factor theorem. It is a factor when the remainder is equal to 0. Okay, so which one of those has a remainder of 0? And the remainder of 0, let me just point it out. The remainder of 0 here is basically when you have, that's why they call it a 0. So the yellow one is the answer. They call this a 0, which is the same thing as this one up here, right? So 4, 0. So here, in your multiple choice, you don't have 4, 0. So how do you go from x equals 4 to one of those? How do you go from a 0 to these, which are factors? And what you're going to have to do is basically just, if I subtract 4, you're going to get x minus 4 equals 0. So there, now I've just created a factor, and that would be choice C. Okay, number 6, match each step to the process of long division. So what do you do first for subtraction? I don't think this will work. Let's see. No, didn't work. We'll just write it out. What do we do first? Well, I think first we're going to have to divide. And then second, then you're going to multiply. And then thirdly, you're going to subtract. And then lastly, you will repeat. Bring down and repeat, right? All right, question number 7. What is the proper way to write the answer for the following problem? The work is shown below, which means you do not need to work out the problem. So they did this division problem for us, and they used what? Synthetic division. Okay, if you think about these two in green, when you do the division problem, what happens is you are actually decreasing the power by 1. Decreasing the power by 1. Let me show you. Look, if you simplify this, you get 2x to the what? Third power. So this 2 here is essentially the third power. And you're not skipping any variables here. So there's no placeholders like a 0x squared or one that's missing, because you have 4, 3, 2, that's a 1, and this is x to 0. So then you can just count down from this one. So this will be a negative 1x squared. Count down, so 3, 2, this will be a 1, so negative 25x to the 1. This will be the 0. And of course we know that the last one is the remainder. Okay, so which one of these has that? We don't have a remainder, so this would be choice B. Alright, number 8. Number 8 doesn't tell me how to do it. All it tells me is division. So I can do this problem. Let's write all the different ways you can do this problem. You can use long division. You can use synthetic division. Now, if it was asking me specifically for the remainder, then I can use a remainder theorem, so I'm going to use one of these two. Okay, I'm going to show you guys long division. Okay, so here is the dividend. And we already kind of outlined the steps above, so you have x plus 7. We're going to divide x into x cubed. And this would be x squared. So x squared, now we're going to multiply. So we just did division, now we're going to multiply x squared times x and x squared times 7. Okay, that would give us a x cubed and a 7x squared. 7x squared would be positive. Then we're going to subtract. Okay, all you have to worry about is just the numbers in front if they're like terms. Oops. 1 minus 1 is 0, so I don't need that one anymore. And then 2 minus 7 would be a negative 5x squared. Then we just repeat by bringing down. And then we're going to be doing that division problem again. This time it's going to be, negative 5x squared goes into x cubed. No. And how did I catch myself there is that when I multiply it, you subtract and they have to equal 0. So it's going to be x going into negative 5x. So x going into negative 5x squared. So negative 5 times x, this is x, cancel your x's, and then you're left with a negative 5x. So let's put a negative 5x here. I'm going to go ahead and multiply now. Negative 5x times x is negative 5x squared, and negative 5x times 7 is negative 35x. Let's go ahead and do that. I'm going to use the red one here and subtract. Negative 5 minus negative 5 is negative 5 plus 5, which is going to give me 0x squared, which means we don't have to write it. Negative 34 minus negative 35 is like negative 34 plus 35, which is going to give me 1x. And then you could just bring this one down. And then you're going to do the same thing. How many times does the green x over here going into this one. Well, they cancel. Cancel is not 0, it's actually 1. So we're going to put a plus 1 here. We're going to go ahead and distribute. X times 1 is going to be 1x, or just x, and 1 times 7 is going to be 7. So let's go ahead and do that. 1x plus 7. And we finish this up by subtracting. And then 1x minus 1x is 0, and 9 minus 7 is 2. So you have a remainder here. And basically, you're going to take all of this here. So the answer is going to be x squared minus 5x plus 1. And the remainder, which is positive, you're going to 2, you're going to put that over the divisor, which is x plus 7. And this would be our answer. I want it red. Okay. Tiana is told to carry out the following polynomial division. Okay. It says the quotient, so this one is the answer. Like, let's just identify that last problem. This up here is the quotient. Or another way of saying it is that if this is the quotient, then the remainder part that they're asking for as a fraction is just this part. Okay? So let's use synthetic division, because I haven't shown that to you. I'm going to take this factor and make it a 0. So set it equals 0, subtract 5, x equals negative 5 is my 0. Okay? I take that and put negative 5 on the outside of my synthetic division. And then all I'm going to do here is I'm going to take all the coefficients, 2, 4, negative 9, and negative 18, and put those right there. So I have 2, 4, negative 9, negative 18. Again, make sure there's no missing gaps there. I'm going to bring down the first one, and then I'm going to multiply diagonally. Negative 5 times 2, which is negative 10. And then I'm going to go ahead and add down, which will give me a negative 6. And then again, I'm going to multiply diagonally. So negative 5 times negative 6, that gives me a positive 30. And then I'm going to go ahead and add down. 30 plus negative 9 is a positive 21. Multiply diagonally, negative 5 times 21. That's going to give me a huge number, negative 105. And then I'm going to add those numbers together. I'm going to add going down, and this will give me a negative 123. Okay, so let's go ahead and write the quotient. The quotient, like we said, let's highlight it. This quotient part is just this part here. Okay, so what is these numbers turn into? Well, again, it's 1 less than the degree that you started with, because this one's x. So this will become a 2x squared. And just count down, minus 6x plus 21. Let's do some magic. Boom. And this part is the remainder. Now it tells us to write it as a fraction. So this would be a negative 123 over my factor, which was x plus 5. And number 10, use the quadratic formula to solve these equations. Write your answers as complex in the form of a plus bi. All right, so I have standard form, everything is to the left side. It is set equal to 0. A is 1, B is negative 4, and C is 13. The quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Alright, a is 1. B is negative 4, so every b value we're going to put in negative 4. Excuse me, C is 13. And let's just repeat everything that we just wrote. Don't forget that negative sign out there. B is negative 4. B is negative 4 squared minus 4. Again, every substitution, every replacement has a parentheses. A is 1. And C is 13, all over 2 times 1. Let's go ahead and simplify this. Opposite of negative 4 is positive 4. We're going to leave that plus or minus till the very end. Negative 4 squared is 16. And I like to do this one all together. Negative 4 times 1 times 13 is going to give me a negative 52 all over 2. Alright, let's keep simplifying this one. 4 plus or minus, double check here, 16 minus 52 is going to give me a negative 36 all over 2. I'm going to simplify the square root of negative 36 here. This is the square root of negative 1 times the square root of 36. The square root of negative 1, here it is equal to I. And the square root of 36, two identical numbers that multiply by 36, is 6. So there in green there is just all 6I. Okay, so then you have to look at these coefficients and recognize that they're all even. So we're going to have to take out the GCF, which is a 2. So 2 plus or minus 3i over 2 times 1. Okay? Remember, you can always distribute to check your answer. 2 times 2 is 4, 2 times 3i is 6i, and 2 times 1 is 2. Okay? Here you can cancel the 2's. Anything left over 1 we don't have to write, so your answer is going to be this. This one tells you to write it in the form of a plus bi, so you just have to write 2 plus 3i as your answer. Okay, those are the questions. Hopefully going over that was helpful for you guys. See you later. Bye.
It started out with graphing and then it went to functions. I'm doing FOIL to solve x. Next is the expressions. Now I have to see if x is equal to or greater than 3. Now you make that point on the x-axis. Wait, was it a positive 3 or a negative 3?